Okay, so once again, very, very comfortable. We should be comfortable taking a product of two binomials. And when we take that product, and after we combine these terms, we get a quadratic. And so in this case, our product, this quadratic, is x squared minus 3x minus 10. Now, what we are tasked with doing is we got to factor this. Meaning, you are given a quadratic equation, and we have to go back to the product of the two binomials. So that's what you first need to do on problem 2A on page 102 of your Springboard textbook. So what they're asking us to do is to start here with a quadratic equation, in this case x minus 3x minus 10, and go back to representing that expression as a product of two binomials. Well, there's a relationship between these coefficients and this constant. There's a relationship between these values and the values that are in those binomials. So the generic form of a quadratic is a x squared plus b x plus c, where a is just the coefficient of your x squared term, or your squared term. B is the coefficient of your x term in your quadratic. And then c is just your constant at the end, in this case negative 10. So in this case, what is my value of a?
1.
Positive 1. What's my value of b? Negative 3. Good. Notice that it's not always going to be a plus. That just means if you're subtracting it, that b is a negative value. And then what's the value of c? Negative 10. Well, there's a relationship between these values, a, b, and c, in our quadratic to this, to these values. Because what we're tasked with doing, I'm just making this up on the spot, so this quadratic is coming from my brain. It has nothing to do with your homework or anything. So I don't want you to be searching around for this. We'll say x squared plus 7x minus 30. This is our quadratic that we need to factor. Now, on your problem on 2A in your Springboard textbook, page 102, it doesn't just have the expression, the quadratic. It has an equal sign, and then it has 0. I'm not forgetting that. I'm going to talk about that, but I just first want us to figure out how to factor these quadratics. We will address the equals 0 in just one second. So, when we factor quadratics, we need to take this expression, this quadratic, and represent it as a product, we need multiplication, a product of two binomials. So I'm going to have x plus or minus something, this would be my first binomial, times another binomial, x plus or minus something. I need to figure out what are these values, these plus or minus something and plus or minus something. So we're going from here to a product of binomials. Well, there's a relationship. When your leading coefficient, so the coefficient of your squared term is 1, then there's a pattern that exists always. And that pattern is the value of b, in this case negative 3. B is the sum of the two numbers. So positive 2 plus a negative 5, that gets us a negative 3. And the value of c, in this case, which is negative 10, the value of c will always be the product of these two values. So positive 2 times a negative 5 is a negative 10. And so that pattern always exists. The reason it always exists is because of this line right here. Because when you distribute each term to the other binomial, you're always going to get this. You're always going to add those two values, so -5 plus 2, you're always going to add those. And your last term's always going to be multiplying those two values together. So that's where B and C are coming from. Again, as long as your leading coefficient is 1, as long as A is 1. You'll deal with some other quadratics in Algebra 2 where the leading coefficient is like 2 or 3 or 4. So, what your Algebra 1 teacher may have taught you is when we're trying to figure out these two values, what they may have taught you is to take your value of C, which in this case is -30, and write all of the combinations of two values whose product is C, in this case -30. So, for example, a pair of numbers whose product is -30 is -1 and +30. This is a pair of numbers whose product is -30. Because we know that these two values that we're searching for right now, when multiplied, they have to equal -30. So maybe it's -1 and +30 that go in. Or it could be -2 and +15. Or it could be -3 and +10. Or it could be -5 and +6. Or reverse all of these. It could be -30 and a +1, or a -15 and a +2, or a -5, oops, sorry, skipped one. -10 and a +3, or a -6 and a +5. These are all of the combinations using integers, using whole numbers, where two values product is -30. But that's not the only criteria that these two values need to satisfy. Yes, these two values need to multiply to equal the value of C, but also these two values need to sum up to equal the value of B. That's when you can find your final answer, or your two values. So which one of these pairs, which one of these combinations will sum up to be a +7? -3 and +10. That's how we choose our plus or minus somethings. It would be a -3 and a +10. So this is factoring. This is factoring quadratics. And what you're doing is you're taking this quadratic and you're representing it as a product of two binomials. And you can always check your answer. And I highly suggest that you do that in any class, science, like chemistry or physics, or any of your future math classes. Always check your answer. Why not? Just why not have that security and that insurance that you know you have the right answer? So let's just distribute these two terms and see if we get this out. So x times x is x squared. X times a +10 is a +10x. Now we're going to distribute the -3 over. -3 times a +x is a -3x. A -3. Ooh, excuse me. I'm sorry. -3 times a +10 is a -30. And then let's go ahead and combine these two like terms. I've got x squared plus 7x minus 30. Well, that checks out. I know that this is correct. I know that I factored correctly because when I took the product, I got back my original answer. So there's no doubt in my mind now that we factored this correctly. So let's just pump the brakes here. Did anyone have any questions about how we factored quadratics? We're not changing the values of anything. We're just representing this quadratic a little bit differently. Just like how we can take the value 10 and represent that as 9 plus 1, or we can represent it as 2 times 5. We're not changing the value, we're just representing it a little differently. But are we okay with factoring? Yes, sir?
When you're getting the factors, like for -30, it's what you can multiply to get C and what you can add to get D.
That's correct. these two values here, which we found -3 and +10, their product needs to be the value of C, and their sum needs to be the value of B. Yes, sir?
It doesn't matter which way signal.
No, not at all. Yeah, we could have switched them. Still correct. Yeah. Good question. Both good questions. Yes, ma'am.
Is there ever an opinion when there's a number next to the X that you talked about? How would that work?
Oh, if you mean there was a value here,
Yeah.
is there a formula for that? Is that what you're asking?
Yeah.
There is such a thing as the quadratic formula. And that's that, I think some of you may have learned it, but it was -b plus or minus the square root, and so on and so forth, all over 2a. That's using the quadratic formula, and that never fails. So if you want to do that, you can. This is the value of a, b, and c. And so that -b plus or minus the square root of, someone help me out. For some reason I'm drawing a blank.
Square root is plus or minus the square root of 4 minus 4 times a.
Right, so underneath the radical in the numerator is b squared minus 4ac. Yeah, man, I don't know why I just drew a blank on it, but it's been a long time since I used that quadratic formula. But yes, that will do the same thing. It'll get you your values. So we're not done yet, because on that problem and what you guys did in Algebra 1, it wasn't just factoring quadratics. However, these were equations. And so now, as I add an equal sign, it's now no longer an expression, but this is an equation set equal to 0. And in your textbook on question 2a on page 102, it says that we need to solve that equation. We need to get what x is equal to. Well, I haven't said that x is equal to something yet. I just have represented this quadratic a little differently. To solve, to get what x is, we have to apply the zero product rule. So please make sure that you have written down the zero product rule. So before I write the definition down, I just want to talk about this and make sure that we can make sense of it in our mind, what this rule is saying. It's almost like a postulate. It's just an accepted rule that's almost common sense. Let's say I have a bunch of terms. And terms can just be constants. Terms can be variables. Terms can be where you have some coefficient and then a variable that's attached to it. So the zero product rule says that if you've got a bunch of terms, whatever they are, and you take the product of all of them, if that product is 0, after it's all said and done, if you multiply all of them together and all of a sudden your product is 0, if that's the case, then one of those terms had to be 0. So kind of let that marinate for a little bit. If you have a bunch of different terms, it doesn't matter what they are. You have a bunch of different terms, and then you take the product of all of those. If the product equals 0, the only way that could have happened is if one of those original terms was 0. There's no way that you can multiply two numbers and get 0. The only way for that to happen is if one of those is 0. Does that make sense? So that's what this rule states. And so I'm going to try to put it as brief as possible. But